Hello friends, in this lecture I will be discussing some of the mathematical tools which are quite important for understanding various concepts of physics. These mathematical tools will help you a lot in understanding various concepts and derivation involved in physics. So let's start. The first mathematical tool is an angle. What exactly is an angle? Let us suppose there is a line OA. If I rotate this line taking O as center, then let's say after some time it reaches a point B. So initially the line was along OA, now the line is along OB. So the amount of revolution, this is the amount of revolution of the line, this is taken as angle, which is mostly indicated by theta. Now, if we rotate a line anti-clockwise, then the angle is always taken to be positive, and if it is rotated clockwise in this direction, then it is taken to be negative. So this is basically what an angle is. Now, how to find out the angle? Let us consider again the line OA. It is rotated about point O. Let's say it reaches a point B. So as you see in this diagram, I have completed a circle where OA is the radius of the circle, and the point B to A, this black line, this one is represented as arc. So the angle is given by angle is equal to arc upon radius. अब ये arc upon radius आया कैसे, तो उसको समझते हैं. Let us consider that the distance between A and B is quite small. If the distance between A and B is quite small, you can see I have drawn a line to B to A. It is considered to be perpendicular to the radius. In physics, we have to assume many things. So the first assumption we are making is, let's say the distance between B and A is quite small. So the distance between A and B is considered to be perpendicular to the radius. So here now BOA is a right angle triangle, and we can apply trigonometric ratios which you have learnt in class 10th. So tan theta is equal to perpendicular upon base. Here the perpendicular is AB, whereas base is OA, the radius. If the angle is considered to be very small, then tan theta is almost equal to theta. Now why does this happen? You will learn later on. We'll study tan series, then you will be able to learn why tan theta is almost equal to theta when the angle is very small. So if I put this over here, I'll get, instead of tan theta I will write theta. Here BA is the arc, whereas OA is the radius. So therefore theta is equal to arc upon radius, or you can say angle is equal to arc upon radius. So these are the basics of an angle which you must remember. Now moving on, there are some conversions. One right angle is equal to 90 degree. You all know this, that right angle is equal to 90 degree. What about 1 degree? See, there are certain smaller units. Instead of writing 57.26 degree, in fact it is written as 57 degree 26 minutes. So what does this minute indicate? So the conversion is 1 degree is equal to 60 minutes, and similarly 1 minute is equal to 60 seconds. These are the conversion or the ways of converting an angle into simpler or smaller units. Now talking about SI unit of angle, SI unit of angle is radian. You must remember this, that SI unit of angle is not degree. What is the relation between radian and degree? Radian is the SI unit of angle. Now what is the relation between them? As you can see, I have drawn a circle with radius OA. Initially the point was at A, now it has moved to point B. So the angle covered You have learned what is angle. The angle covered here is 180 degree. Now as we know, angle is equal to arc upon radius. So the here angle covered is 180 degree. Arc, this will be the arc, and it is equal to circumference of a semicircle. So that will be equal to pi r. We are considering the radius to be r. So angle 180 degree, arc will be the pi r and radius r. So cancelling we get 180 degree is equal to pi radian, or you can say 1 radian is equal to 180 degree upon pi. So this is the conversion or the relation between radian and degree. 1 radian is equal to 180 degree upon pi. Now moving on, we'll learn trigonometric ratios of allied angles. You must have learned trigonometric ratios in class 10th. The trigonometric ratios mostly sin theta, cos theta, tan theta, cot theta, sec theta and cosec theta. You must have learned a table where you have values for different angles. For example, you have values for 0 degree to up to 90 degree. What about if the angle is greater than 90 degree? Then how are you going to find out that? For that, we'll learn trigonometric ratios of allied angle. Now what basically are allied angles? If sum or difference of two angles is either 0 or multiple of 90 or pi by 2 in the radian. In the case of radian, I'll write pi by 2 radian because 1 radian is equal to 180 degree by pi. So solving 90 degree will be equal to pi by 2 radian. Then both angles are said to be allied. Both angles are said to be allied means, let's say there are two angles, 40 and 50. Then both of them are allied angle because their sum is 90 degree. Now moving on, how to find out angles which are other than 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. For this we'll use quadrant system. As you can see, I have drawn a line. There are 4 quadrants. 0 to 90 is considered as first quadrant. 90 to 180 is considered as second quadrant. 180 to 270 is considered as third quadrant, whereas 270 to 360 is considered as fourth quadrant. It means if the angle is between 0 to 90, it will lie in the first quadrant. If the angle is between 90 to 180, it will lie in the second quadrant. Similarly, if the angle lies between 180 to 270, it will lie in the third quadrant, and between 270 to 360, it will lie in the fourth quadrant. As you can see, I have written 4 letters A, S, T, C. Now what does these letters indicate or how to remember them? The simplest way to remember them is आज से trigonometry चालू, ASTC. आज से trigonometry चालू. What is A? A means all the trigonometric ratios will have positive value. All the trigonometric ratios means sin theta, cos theta, tan theta, cot theta, sec theta and cosec theta. All of them will have positive value. As you have learned the table in class 10, none of the value was negative. Reason being, the angle varied from 0 to 90 degree. So all the values were positive. So if the angle lies in the first quadrant, all, A stands for all the trigonometric ratios will have positive value. Now talking about S, S stands for sine, and reciprocal of sine is cosec. It means between 90 to 180, all the angles for sine and cosec will have positive value. Means, for example, sine 120 will have a positive value, whereas cos 120 won't have a positive value because from 90 to 180 only sine and cosec are considered to be positive, rest all are considered to be negative. Moving on from 180 to 270, T stands for tan and reciprocal of that is cot. Means for all those angles between 180 to 270, only tan and cot will have positive values. For example, if I take 210 angle 210, then sine 210 will be negative, whereas tan 210 will be positive. Moving on from 270 to 360, C stands for cos, and reciprocal of that is sec. So all those angles between 270 to 360, only cos and sec will be positive, rest all will be negative. And this cycle goes on. For example, for angle greater than 360, तो यहाँ पे मैंने 360 लिख दिया है. उससे बड़ा वापस all positive up to 450. Greater than 450, less than 540, sin cosec positive. 540 to 630, tan cot positive. 630 to 720, cos and sec positive, rest all negative. This cycle will keep on going. While finding out values for different angle, we must remember some certain rules. And what are those? As you can see, sine 90 plus theta. 90 plus theta means it is in second quadrant. Sine is positive, but if it is 90 over here, sine will convert into cos and this angle will be as it is. So sine 90 plus theta will be equal to cos theta. But what about cos 90 plus theta? As you know, in second quadrant, cos is negative, so I have put a negative sign over here. Since it is 90 over here, cos will convert into sine and theta as it is. So cos 90 plus theta will become minus sine theta. Moving on, tan 90 plus theta. Again, tan is negative in second quadrant, so I have written minus. Since it is 90 over here, tan will become cot and theta as it is. So tan 90 plus theta is equal to minus cot theta. Similarly, cot 90 plus theta will be equal to minus tan theta. Same rule will be applied over here. Moving on, cosec 90 plus theta. 90 plus theta means second quadrant, where sine and cosec are positive. Let me show you this once again. This is the second quadrant. 90 plus theta means sine and cosec positive, rest all negative. So cosec 90 plus theta means second quadrant. In second quadrant, cosec is positive, so I have written positive over here. Since it is 90, cosec becomes sec. So it becomes sec theta. For sec 90 plus theta, it will be minus cosec theta. So this is some conversion you should remember. Now talking about 90 minus theta, since 90 minus theta will be in first quadrant, all the trigonometric ratios will be positive, so sine become cos, cos becomes sine only when it is 90 over here. And all of them are positive. Same rule goes or is applied over here, but they all will be positive because all of them are in first quadrant. Now let's see some example for better understanding. For example, sine, you have to find sine 120 degree. Now how can you write 120 degree in the form of allied angles? So you can write sine 90 plus 30. Sine 90 plus 30, 90 plus 30 is 120. Now this is 90 over here, sine will become cos. 90 plus some angle means it is in second quadrant. The angle as it is, and sine is positive in second quadrant. So sine 90 plus 30 will become cos 30, and value of cos 30 is root 3 by 2. So sine 120 will be equal to root 3 by 2. Similarly, if I find out cos 120, again I'll write 120 in the form of allied angle. So cos 90 plus 30, it will be in second quadrant. Cos in second quadrant is negative, so I've written negative. Cos 90 plus theta will become sine. So sine, here theta is 30 degrees, so minus sine 30 degree. Sine 30 is half, so minus half. Value of cos 120 is minus half. So using these formulas, you can find out various allied angles. Using sine or 90 degree is quite a difficult task. So you can convert it in the form of 180 degree also. If it is 180 over here, sine does not change, or cos, tan, cot, sec, none of them changes. Only you have to remember in which quadrant do they lie. For example, sine 180 minus theta. It is in second quadrant. 180 minus theta. 180 minus theta is second quadrant. Sine is positive. So sine is positive, angle as it is. Since it is here 180, so sine remains sine. Talking about cos, cos 180 minus theta. Again second quadrant, cos is negative, so minus cos theta. Similarly, these rules are written over here. If I talk about plus theta, 180 plus theta, it means it will be the third quadrant. तीसरा क्वाड्रेंट आ जाएगा 180 प्लस में, तो यहाँ पे सिर्फ tan और cot पॉजिटिव है, रेस्ट ऑल आपके नेगेटिव है, मीन्स साइन विल बी नेगेटिव. तो साइन 180 प्लस थीटा माइनस साइन एंगल एज इट इज. So you must remember this. Now it might be difficult for you to remember, so I have written a general formula. See, sine n pi by 2 plus minus theta. If n is even, let's say 2, then if n is equal to 2, then sine pi plus minus theta, pi is 180 degree, so sine will remain sine and theta. But if n is odd, so sine n pi by 2 plus minus theta will become cos theta, cos will become sine, tan will become cot, as we have discussed over here. Here 90 can be written as 1 into pi by 2. 90 can be written as 1 into pi by 2, where n is odd. If n is odd, sine will change into cos, and so on. But if here 180 can be written as 2 into pi by 2. It means if n is even, sine will remain sine. If n is odd, sine will convert into cos. For simplification, it is better to always convert in this form. It will be easier to remember. Now let us understand that concept by using some examples. For example, I need to find out tan 150. How can I write 10, or you can say 150 degree? It can be written as 180 minus 30 or 90 plus 60. Now you can see 180 can be further written as 2 into 90. Means it is an even multiple of pi by 2. And as we know, whenever it is an even multiple of pi by 2, 10 remains 10. The first thing, since it is an even multiple, 10 will remain as 10. Now 180 minus something, it means it will be in the second quadrant. And in second quadrant, 10 is negative, so I have put a negative sign over here, and the angle as it is. So tan 180 minus 30 or tan 150 is equal to minus tan 30, which is further equal to minus 1 by root 3. You can solve it in other way also. Tan 90 plus 60. Now here it is an odd multiple. So whenever it is an odd multiple of 90, 10 converts into cot. Again 90 plus 60, it is in second quadrant. Since it is in second quadrant, 10 is negative, so I have put a negative sign. 10 converts into cot, and the angle as it is. So minus cot 60 is again minus 1 by root 3. Let us see some other example. For finding out cos 330, I can write cos 330 as 360 minus 30, and 360 can be further written as 4 into 90. So cos 4 into 90 minus 30. Again here it is an even multiple of 90. So cos will remain cos. 360 minus something, it means it is the fourth quadrant. 360 minus something, it will lie somewhere over here, and it is the fourth quadrant. Here cos is positive. So positive cos 30 is given by root 3 by 2. Moving on, tan 390. Now how can I write 390? I can write 360 plus 30. So tan, again 360 can be further written as 4 into 90 plus 30. Here again it is an even multiple, so tan will remain 10. 360 plus something, it is mean it lies in the first quadrant, and in the first quadrant all the trigonometric ratios are positive. So it is positive tan 30, which is given by 1 by root 3. Another most important tool or mathematical tool which will be widely used in physics is calculus, and first of it is differentiation. Now what basically differentiation is? Let us study. Let's say y is any variable which is a function of x. It means if you change the value of x, y will change. So it is written as y is equal to f of x, means y is a function of x. For example, y is equal to x square. Right? Y is equal to x square. As x changes, y will correspondingly change. So y is dependent upon x. So y is considered to be a function of x. So if x changes, y will also change. Now let us assume that there is a small change in x, which is given by delta x. Here this triangle stands for delta, which stands for change. So there is a small change in x which is given by delta x. If there is a change in x, there will be a corresponding change in y. Let us assume that change to be delta y. So y plus minus delta y will be equal to f x plus minus delta x. If delta x is added, the change in y will also add up. If delta x is subtracted from x, there will be a subtraction of delta y from y. So in this way, y will vary. Now if I need to find out change in y with respect to change in x, then how can I find out? So delta y by delta x will be equal to f x plus delta x minus f of x upon delta x. So this is a way of finding out change in y with respect to change in x. What if change in y and change in x are very small? So it is written if limit delta x tends to 0, means change in x is not 0 but it is very small. Then instead of writing delta y by delta x, we write dy by dx. We can't cancel out this d. dy by dx means small change in y with respect to small change in x. This is known as differentiation, or dy by dx is also written as differentiating y with respect to x. It is not, you can't cancel out d and d. It means dy by dx means here small change in y with respect to small change in x. What does this actually mean? Let us assume I've taken a curve y is equal to some f of x. Now I need to find out the slope of this curve. Then how would I find out slope? Let's say these are 2 points. So here is a tangent drawn and this is the angle. This is known as slope. If we consider it as a right angle triangle, then slope tan theta will be equal to perpendicular upon base. So I have written slope is equal to y2 minus y1 upon delta x. Now y2 minus y1 can be written as delta y. The slope can be written by delta y by delta x. What if they are quite small? Then slope can be further written as dy by dx. It means differentiation only indicates the slope of a given curve or a given equation. Now we need to remember some important formula for finding out differentiation or using differentiation. Let us study them. First, if y is equal to x to the power n, let's say y is equal to x square, x cube, whatever, then small change in y with small change in x means differentiating y with respect to x will get n into x to the power n minus 1. For example, if y is equal to x square, then dy by dx will be equal to 2x to the power 1. In this way you will differentiate. Moving on, y is equal to c, where c is a constant. Then how would you find out change in y with respect to change in x? As there is no x, y is constant, so there will be no change in y. For example, y is equal to 5. So it will always remain y is equal to 5. It won't change. So change in y with respect to change in x, it will be 0, because y is independent of x. It is not dependent on x. So you can't find out change in y with respect to change in x because there is no x in the equation. Hence dy by dx will be equal to 0. Moving on, third type of equation, y is equal to c x to the power n, where c is again a constant. As we know, constant you can't differentiate it, means you can't find out change. So dy by dx will be equal to c as it is dot x to the power n. Now how do you solve x to the power n? You solve it by n x n minus 1. So y is equal to c x to the power n, then dy by dx c n x n minus 1. Moving on, if y is equal to log to the base ex, then dy by dx is always equal to 1 by x. Next, y is equal to e to the power x, then dy by dx is again e to the power x. There is no change. Moving on, if y is equal to a to the power x, then dy by dx is a to the power x log e base a. Next, y is equal to u plus minus v, where u and v are functions of x. Then you will differentiate them separately. Then dy by dx will be equal to du by dx plus minus dv by dx. Let's take an example. For example, y is given by x square plus log to the base ex. Then you have to find dy by dx. Here x square can be considered as u. Log e to the base x can be considered as v. You need to differentiate them separately. X square, x to the power n. So you will get n x n minus 1. On solving you will get 2x. Log x is differentiated as 1 by x. So first you will differentiate u with respect to x. Then you will differentiate log x with respect to x. So you will get 2x plus 1 by x. What if I ask find dy by dt? In the same example, if I ask dy by dt, then what would be the answer? The answer will be 0, as y is not dependent on t. It means y is independent of t. So if I talk about finding out change in y with respect to t, then these quantity will become constant as they are independent of t. In that case, dy by dt will be equal to 0 because these term will behave as constant in that case. Moving on further, what if two functions are multiplied, that is u into v? Earlier we have studied u plus v or u minus v. Here we will study u into v. So this is the formula for finding out dy by dx. Take the first function as constant, differentiate second, add, take second as constant and differentiate the first. I will explain you this by using an example. Let's say y is equal to x square into log e to the power x. Consider this as u, consider this as v, this as u and this as v. So first I will keep u as it is and differentiate v. So log to the power base ex is 1 by x. Then I have kept v as constant and I have differentiated u. So x square becomes 2x. So it will become x plus 2x log e base x. I can take out x constant. It will become 1 plus 2 log e base x. Moving on, Moving on, what if both of them are in a fraction form? Then this is the formula for finding out dy by dx, which is given by v du by dx minus u dv by dx upon v square. You must remember this formula as they are very useful in solving various numericals. Now we'll see differentiation of trigonometric function. What if y is equal to sin x? Then dy by dx will be equal to cos x. Similarly, if y is equal to cos x, dy by dx is equal to minus sin x. A small trick to remember: whenever a trigonometric function starts with c, whenever a trigonometric function starts with c, its differentiation will always have a negative sign. So y is equal to cos x, then dy by dx is equal to minus sin x. Moving on, if y is equal to tan x, then dy by dx is equal to sec square x. Next, y is equal to cot x. Again, see, it must have a negative sign. So dy by dx is equal to minus cosec square x. Y is equal to sec x. Dy by dx is equal to sec x tan x. Y is equal to cos x. Again a c. So here it is written negative sign. Dy by dx is equal to minus cos x cot x. Now let us consider some example for understanding. For example, y is given by x square plus 3x cube plus 3t square. Now I need to find out dy by dx. So x square will be 2, x power 2 minus 1, that is 1, 3 constant as it is, x cube. So you can write, you are using formula this. So it will become 3x square. Now 3t square, it is independent of x, so it will behave as constant for y, so differentiation will be 0. So you'll get 2x plus 9x square. Next, y is equal to root x. Root x can be written by as x to the power half. So dy by dx n x n minus 1, so n is half, x n minus 1, half minus 1 is minus half, so you'll write 1 by 2 root x. Moving on, y is equal to 3t square plus 9t. You need to find out dy by dx as well as dy by dt. Now dy by dx has to be 0 because there is no x over here, and these quantity will now behave as constant. So change in y with respect to change in x has to be 0 because there is no x in this equation. But change in y with respect to change in t, yes, it is possible. How would you find out? 3t square, you can write 3 into 2t, t square will be 2t. 9t, 9 is constant, t to the power 1, to 1 into t to the power 1 minus 1, that is 0. Any object to the power 0 is 1, so you will get 6t plus 9. Now let us study some complex functions. In this we will use chain rule. What if I ask if y is equal to e to the power sin x and then find dy by dx? Now how to do such type of equations? Now there are two functions, first is e, other is sin x. So consider the above one as x, so it will become equal to e to the power x. Now what is differentiation of e to the power x? It is e to the power x. So I have written again e to the power x. Instead of x I will write sin x. Now differentiate the one which you have assumed as x. So sin x, differentiation of sin x is cos x. So it becomes e to the power sin x into cos x. Let me repeat it once again. Y is e to the power sin x. You don't know how to differentiate such thing. So consider sin x to be x. The differentiation of e to the power x is e to the power x. Instead of x you will write sin x. Now differentiate the one which you have assumed. You have assumed sin x as x, so differentiation of sin x is cos x. You will multiply it, so this is the answer. Let's see another example. Y is equal to log to the power base e tan x. Now how to differentiate it? Consider tan x as x. Log x is 1 by x. So 1 by x, here 10x, you write 10x. Now differentiate which you have assumed. You have assumed 10x. The differentiation of 10x is sec square x. So you'll get sec square x into 10x. Let's take some another example. Y is equal to sine cube x. Now how to solve this? We don't know how to solve sine cube x, so consider whole sine x as x. So it can be considered as y is equal to x cube. What is differentiation of x cube? It is 3x square. So dy by dx is equal to 3x. X is sine over here. So sine square x. Now differentiate the one which you have assumed. You have assumed sine x as x. So differentiation of sine x is cos x. So this will be your answer. Let's say some other type of question. Let's y is equal to sine theta and x is equal to cos theta. And you have to find dy by dx. Now to find dy by dx. You know y is a function of theta and x is also a function of theta. So first differentiate them with respect to theta. So dy by d theta sin theta will be equal to cos theta. Dx by d theta cos theta will be equal to minus sin theta. Now divide both of them. So dy by dx can be written as dy by d theta upon dx by d theta. So you'll get cos theta upon minus sin theta will be equal to minus cot theta. Thank you for watching. In the next lecture, we will be discussing about various formulas of trigonometry and integration.